Let's talk about temperature. Now, the AP exam itself is not going to have you do the temperature conversions either as a standalone question, as you might see in the multiple choice portion of the exam, or a kind of intermediate step in one of the free response questions. You're not going to be doing temperature conversions except for degrees Celsius to kelvins, or maybe vice versa. And that's totally okay with us because this is the easiest conversion that has ever existed in the history of conversions. Because no matter what, the temperature that you have in degrees Celsius, in order to say that same temperature in kelvins, you simply add 273. Now, if we want to get like really precise here, we'd go 273.15. Okay, but for the vast majority of the calculations that we will ever see, 273 is more than good enough. So 273, really remember 273 if you're going from degrees Celsius to kelvins. Or if you want to convert a Kelvin temperature into degrees Celsius, you are simply going to subtract 273. And one of the reasons is, as we look down at this chart, is that the difference, this difference of 273 is based on what the scale is meant to measure. The Kelvin scale is dedicated to movement, right? So 0K, which is also known as absolute zero, is the temperature at which there is absolutely no movement, right? The Kelvin scale is designed to measure movement. So when there's no movement, we call it, well, it's 0K. It's no movement, so it's absolute zero. You can't have any less motion than still. Now, to be perfectly honest, a few years ago, well, I guess it's getting more and more these days, this absolute zero, which was thought to be 0K being this minus 273.15 degrees Celsius, somebody in lab was actually able to make this just a little bit colder, just a couple of decimal points colder than this. That isn't a blow to the idea of absolute zero. What they're really able to say is, at this 273.15, the point at which scientists had believed that there was no more molecular movement, there actually was a small amount, and they were able to reduce that even more. And so that absolute value, that absolute zero value, is in a little bit of flux, but it's not crazy, right? It's not insane. It has to do with the precision of the instrumentation that scientists are using. The idea is still cool. They're not debunking anything about absolute zero or the kinetic molecular theory. Just a little update, but we're just going to rock with 273 as this magic number. Now, the secret to just being able to add 273 or subtract 273 is because 1 degree Celsius is the exact, off the camera, is the same thing as 1 Kelvin. And by the way, you do not say degrees Kelvin, you just say 1 Kelvin, 2 Kelvins, 3 Kelvins. Well, I guess some people say it plural, like, 10 Kelvins. Some people just say 10 Kelvin. That's fine. The point is, do not say degree. Do not say degree Kelvin. But 1 degree, see that degree sign right there? 1 degree Celsius is the same thing as 1 Kelvin. So with the Kelvin scale, we're starting at movement, right? We're starting at no movement, and each increment of 1 Kelvin is the same increase as 1 degree Celsius. The only difference is the degrees, the degrees Celsius scale is starting at 0 degrees Celsius is the freezing point of water. And so the Celsius scale is based off of water. Notice that these really round points at 0 degrees Celsius, that's the freezing point of water, the point at which there's a transition between the liquid and solid states. The boiling point at 100 degrees Celsius is the boiling point of water, the transition from the liquid to the gas state of water. And so this is based around H2O and its phase changes. But the difference between the freezing point of water and the boiling point of water is 100 degrees Celsius, right? That's the difference there. The difference between the boiling point of water on the Kelvin scale and the freezing point of water on the Kelvin scale is 100 kelvins, right? So because 1 degree Celsius is the same thing as 1 Kelvin. Other kind of interesting information we have right here, the Fahrenheit scale, which is super annoying, to be perfectly honest. It's based on like random, random stuff. It's not random. So what this guy thought was important. But the freezing point of water is 32 degrees Fahrenheit. A comfortable room temperature, at least for me, would be 68 degrees Fahrenheit. It's about 20 degrees Celsius on the Celsius scale. And water will boil at 212 degrees Celsius. And I'd like to point out the difference between the boiling point of water in Fahrenheit and the freezing point of water in degrees Fahrenheit is not 100 degrees. That's not the difference, right? That's not the difference. Because 1 degree Celsius, it does not equal 1 degree Fahrenheit. It does not. It does not. They are the same thing, right? So notice that a degree of temperature change on the Celsius scale represents the same quantity of change on the Kelvin scale, but not the same quantity of change on the Fahrenheit scale.